Hello, this is Pramiti Barua and Joseph Blankenship. Today we are going to present our project on evolution in small-scale open source software, a case study. Other studies such as Godfrey et al. Found that the open source project Linux was growing at a superlinear rate. So we are curious about other open source projects and how they grow and change. So our research question is, do Lehman's Law 1 and 6 apply to smaller open source projects? Open source software projects support the general advancement of technology for the community. Trends are always changing and the growth of the open source model today may not match the growth in other projects. So our motivation is to better understand the trend among several open source projects. These two Lehman's law help us understand how well an open source project is developing. These are the two laws concerning growth that supports our motivation. We collected 10 open source projects in total. Let's briefly review them. Sprite has support for different color, profiles, and modes. ClickHouse is a column-oriented database management system that creates real-time data reports. DXVK is a Vulkan-based translation layer for Direct 3D. The project FMT is a formatting library that is an alternative to C Studio and C++ IO streams. Godot is a cross-platform game engine that creates 2D and 3D games. libtorrent is a C++ library that the BitTorrent protocol. OpenCC is a project that supports conversion between traditional Chinese, simplified Chinese, and Japanese kanji characters. The project Pixel Game Engine is a pixel drawing framework for game development. PHP is a PHP game console emulator. Terminal is an application for those who use command line tools and shells.
Godot is the most popular project with over 1,500 contributors and the most stars. Pixel Game Engine is the smallest project with 3 contributors and the least stars. These are contributors active on GitHub. ClickHouse has the most number of versions, 77 in total. The least was OpenCC with only 11 versions. We found the following metrics for each version of each project: lines of code, number of classes, number of functions, number of declarative statements, which includes things like variables and constants, and number of macros, which includes statements like define and include. We generally do not include slock in most of our analysis because it's so similar to lock in terms of the trend. We did not want to include open source projects that had a private company backing. This means that the company pays developers to work on it, along with some other things, and that it's eventually released to the public. So we checked for this before selecting projects. We made sure the projects had at least 70% C++ code. If not, we made sure the second most used language was C. If this criteria was not met, we did not include the project. This was because of our limitations with SourceML. We automated a few different processes because there were so many projects and so many versions. We use SourceML. SourceML is a tool that converts source code into an XML file. Then we can search the XML for tags we want. For example, we can find all of the classes with one search. SourceML only does C, C#, C++, and Java. We also analyze the source code with CLOC. CLOC is a tool that counts the number of blank lines. It can detect and count most programming languages, including how many lines of each language are in the version. These are our results. The version numbers all begin with 1 and are incremented by 1 in the diagrams here. In terms of metrics, like functions, declarative statements, and macros, most of the projects are constantly changing, which adhere to Lehman's sixth law. So the functionality is generally increasing in every project. However, classes are relatively stable across the evolution, while a number of declarative statements, functions, and macros change more. Pixel Game Engine, number 8 on the graph, changes the least in terms of line of code, number of classes, number of functions, and number of declarative statements, etc., over all 16 versions. In contrast, OpenCC changes more rapidly over just 11 versions in the same kind of metrics. This may be explained by the number of active contributors on GitHub. Pixel Game Engine only has 3 active contributors, where OpenCC has 78. Every other project shows continual change through our metrics. Terminal shows an odd spike, which is then evened out. The function, classes, and declarative statements were constantly changing as the software evolved.
Now let's talk in detail about some projects. Sprite is declining in lines of code, but the functionality in terms of number of functions remains stable. There is also a strange dip in version 19 which suggests an anomaly. It follows the first Lehman's law. We looked into some of the updates on the homepage for this project and found that more functionality was being added. This was an interesting project that was unlike the other. Godot is interesting because the number of macros decreased while the number of declarative statements and functions are stable. At the same time, there is a sharp increase in the last version that is superlinear. The open source model can be powerful when there is a lot of interest. Both Lehman's laws apply. OpenCC has a sudden drop in declarative statements while the functions and macros continue to increase. One explanation is that some library of characters was dropped for a few versions but then added back in again. The project is in its early stages and many others had high variability towards the beginning of the project. We think both Lehman's laws are applied. Terminal had an interesting spike in one version, but the same spike is not seen in log. There was also a strange drop off in the last version, while log remained unchanged. In general, both laws apply. Growth in general trended linear, with occasional sections that were superlinear or sublinear. The dots on the graphs represent each version. From this view, it's easy to see that the number 7, OpenCC, had much fewer versions. Also, you can see that the number 8, Pixel Game Engine, has almost stalled. Remember, this has just 3 public contributors in GitHub. So, we can see that most projects follow the Lehman's first law here.
Now on to threats to validity. So some languages were not supported by SourceML, and they might have contained some important information. For example, if there was some Python code in the project. Also, we could not read some of the SourceML output files, but they could be read by Python, so we couldn't confirm exactly what was on them. There might have been some download errors, possibly some repeats from unusual naming conventions, for example. Basically, some projects might have been just too small or new to study. They might not have been mature enough to be compared in comparison to others to warrant any other kind of comparison. In conclusion, open source software projects are constantly adding new features and changing. The growth is generally linear. Most of the change in functionality is through functions, macros, or declarative statements. The classes of an open source software project do not change much from when a project begins. Projects mostly follow Lehman's laws 1 and 6. Some projects grow constantly, but their functionality in terms of functions and classes do not. Some open source projects may add functionality, but the lines of code may actually decrease. In general, open source software growth shows a lot of volatility in terms of functionality. These are our references. Have a great day.